I'm now moving on to Chapter 3, Lesson number 3, which covers the power rule. So for lesson number 3 here, we need to start off with example number 1, where we need to find the derivative of the following functions. Alright, so example number 1. So if y equals to 3, and if I want to find the derivative, well, since 3 is a constant, the derivative of a constant is simply going to be 0. Okay, so if you visualize that on a graph, y equals to 3 is a horizontal line, and the slope of a horizontal line is 0. So that's your answer. Question number 2, what is the derivative of a constant? Well, a derivative of a constant is always 0, so questions 1 and 2 are very similar. Question number 3, y equals to negative 5x to the power 4. So you take this 4 and you want to bring that down and multiply that with the negative 5. So negative 5 times 4 is negative 20x, and then you reduce the power by 1, so 4 minus 1 is 3. Alright, so for question number 4, I have a 6 here, so the 6 will multiply with the 3 over 2. So 6 divided by 2 is 3, and 3 times 3 is 9, so that will be 9x to the power of, well, if I subtract a 1 on the 6, I get a 5 here, so y prime would be 9x to the power of 5. Okay, let's move on to a few other questions here. Question number 5, 6, 7, and 8. For question number 5, I recommend you to rewrite this in terms of a power. So rewrite this radical in terms of an exponent here. So this would be x to the 2/3. And once you write the question like that, then it's pretty easy to apply the power rule. So this guy will come into the front. So that's 2 over 3 x. And then you subtract 1 on the exponent. So 1 is the same thing as 3 over 3. So 2 minus 3 is going to be negative 1/3. So although that is a correct answer, if you want to rewrite this as 2x over 3x to the, whoops, sorry, that is an acceptable answer, but if you want to just do one more step, you can rewrite this in terms of a positive exponent, so it'll be 2/3 x to the 1/3. So this is okay, and this is okay as well. Moving on to question number 6. So for question 6, I would rewrite the radical in terms of a power. So this is y equals to 2x to the 1/2. And then you can bring the, when you take the derivative now, you can bring the 1/2 to the front. So 1/2 times 2 is 1x. And then you subtract 1 on the power. So subtracting 1 is the same thing as subtracting 2 over 2. So 1/2 minus 2 over 2 is negative 1/2. And if I rewrite that, that's the same thing as 1 over x to the 1/2. Okay, moving on to question number 7 here. So for question 7, I would rewrite this so that we have we don't have any powers on the denominator. So this would be the same thing as y equals to negative 2x to the negative 3. Then take the derivative. And then this power right here will multiply with the leading coefficient. That will give you a 6x. And then you minus 1 here, and that will be negative 4. And if you rewrite that, that's the same thing as 6 over x to the power of 4. Alright, so moving on to question number 8. And once again, for question number 8, you want to rewrite this so that you don't have a radical. And if you don't have a radical, it would be x to the power of 1/2. And then if you write this so that you don't have any denominators, it would be y equals to 2x to the negative 1/2. And now you can apply the power rule for derivatives. Here's your power. Negative 1/2 times 2 is negative 1x. And then you need to subtract 1 on the power, which is the same thing as minus 2 over 2, which will be negative 3 over 2. And that's going to be y prime. If you want to clean this up, this is the same thing as y prime equals to negative 1 over x to the 3 over 2. Alright, let's move on to example number 2 now. So sometimes taking derivatives can be very, very quick if you understand the rules. Okay, so for example number 2, question number 1, I don't see any problems with this, so we can go right into the derivative. So this 2 will multiply with the 3, giving you a 6x, and then you subtract 1 on the power, so 2 minus 1 is 1, minus, well, the power of that, sorry, if you apply the power rule there, it's going to be negative 5, and the derivative of a constant is going to be 0, so your final answer is Let me just rewrite this as 6x minus 5. So that's your final answer for that one. All right, so for question number 2, if you want, you could rewrite this as 1/3 x squared plus 1/2 x plus 1. And then you can go ahead and take the derivative. So the 2 would multiply with the 1/3. That would give you 2/3 x. And then you minus 1 in the power. That would give you 1 plus, well, the derivative of a constant times a variable is just the leading coefficient, which is just 1/2. And that's your final answer. So if I rewrite that, that's going to be y prime equals to 2/3 x plus 1/2. So that right there is your final answer. And for part 3 here, we can go right into the derivative, f prime of x. Okay, so then the 4 would multiply with the -3, giving you a -12x, and then you subtract 1 in the power, and that will be x to the power 3 plus. Well, if you have a coefficient multiplying onto a variable, then the derivative of that is just the coefficient, which is 1/2. So that's your final answer there, -12x cubed plus 1/2. All right, let's move on to question number 4, 5, and 6. For question number 4, I would rewrite the problem by getting rid of the radical. So this is y equals to 5x cubed minus 2x to the 1/2. And now you can take the derivative by using the power rule. And if I do that, the exponent will multiply with the leading coefficient. So 5 times 3 is 15. So 15x. And then you minus 1 from the power to get a 2 there. And then you do the 1/2 times the 2, which will give you 1x. And then you need to minus 1 on the power. So that's the same thing as minus 2 over 2, which is -1/2. And if you want to rewrite your answer by cleaning things up, you can get 15x squared minus 1 over x to the 1/2. And if you want to do one extra step here, anything to the power of 1/2 is just the square root of that variable. Okay, let's move on to question number 5 now. Question number 5, I'm just going to rewrite this before I take its derivative. I'm just going to put the 15 in front as a coefficient. It might be a little bit easier to take the derivative. Alright, so now we can take the derivative now. So now we have f prime of x. Now the derivative constant is 0. And the derivative of this expression right here will be -1 over 15. And then for the third term, the 3 would multiply with this guy. So that will be plus 3 over 15 x squared. I need to subtract 1 in the power. And then 5 times this guy will be -5 over 15 x to the 4. And then all we can do now is just clean this problem up. That's going to be -1 over 15 plus 3 over 15 is 1 over 5 x squared. And 5 over 15 is 1 over 3 x to the power of 4. And that's your final answer for that one. All right, let's move on to question number 6 now. For question number 6, I would rewrite this so that I don't have any variables on the denominator. So if I rewrite that, that's going to be y equals to 1 plus x to the -1 plus 2x to the -2. And now I can take the derivative. All right, well, the derivative constant is 0. And then for the next term, the -1 will go in front, giving me a -x to the power of -2, because I need to subtract 1 on the power. And then on the last term, it would be -2 times 2, which is -4x, and then -1 there would be -3. So if I clean that up, I would get -1 over x squared minus 4 over x cubed. Okay, let's go on to question number 7 now. Hopefully we can speed through some of these if the questions are a little bit nice, but we do have to rewrite some of these before we can take its derivative. So question number 7, I would rewrite this as x over 4 plus, well, 2 over 4 is 1/2. And then if I take its, if I want to rewrite this one more time, it's the same thing as 1 over 4x plus 1/2. And this is like the equation y equals mx plus b, and the slope of that is just a quarter, so the derivative is 1 over 4. All right, question number 8, I would rewrite this again. This time I would rewrite the radical as a power, so this would be 2x to the 1/2 plus, And this expression here would be 2x to the negative 1. And then I can take its derivative, the 1/2 times with the 2, giving you a 1x, minus 1 on the power, so that'll be negative 1/2. And then this negative 1 times that times the 2 would be a negative 2x to the negative 2. So if I clean this answer up, it'd be it'd be 1 over x to the 1/2. Let me just get my eraser here. Okay, so it would be 1 over x to the 1/2 minus 2 over x squared. Okay, so this guy right here is that guy right there. This guy right there is that guy right there. And hopefully that's an okay answer for everyone. Let's move on to question number 9 now. G of x. So once again, we need to rewrite this before we take its derivative. So this is going to be 3 over x to the 2/3 minus 2 over x to the 3 over 2. All right, so then we need to rewrite this one more time. So this would be 3x to the negative 2/3 minus 2x to the negative 3 over 2. Okay, so we've simplified the problem so that we've written everything in terms of a power. Now we can use the power rule by taking the powers and multiplying them with the leading coefficients. So g prime of x equals 2. All right, so there's a 3 here, so it'll be 3 times this negative 2/3 x to the negative 2/3 minus 1, which is the same thing as 3 over 3. And then I have the minus 2 onto this guy, which is negative 3 over 2. Starting to run out of space here. X to the negative 3 over 2, and then I need to subtract 1 there, which is the same thing as minus 2 over 2. And finally, hopefully we can clean this up now. If I clean the problem up, this 3 and that 3 will cancel off, giving you a negative 2 x to the negative 5/3. This 2 and that 2 will cancel off. This minus and that negative 3 will give me a plus 3 x to the negative 5/3 again. And if you just want to finish this off with positive exponents, it would be negative 2 over x to the 5/3 plus 3 over x to the oh sorry, not 5/3, but there's supposed to be a 2 here. 5 over 2. Okay, so I do apologize for that. I already made a mistake in the video here. This is 3x to the negative 5 over 2. Okay, so sorry about that. Okay, let's move on. Now we move on to example number 3. More derivatives using the power rule, and for question number 3, we need to simplify everything again. So if I go ahead and simplify part 1 of example number 3, I could write this all into in terms of 3 individual fractions. All right, so this x cubed is dividing onto everything in the numerator. So this is one of the techniques that we teach kids in the grade 9 curriculum. And then we can simplify this using exponent rules again. So 4 and the 3's will cancel off, giving you 3x plus, well, there's more 3's on the bottom than the numerator here, so this would be 2 over x minus, if I write this in terms of power, it would be negative x to the power negative 3. And this middle term right here, although 2 over x is correct, I mean, that's the same thing as, oh, sorry, can't erase that. That's the same thing as 2 to the power of x minus 1. Sorry, 2x to the power of negative 1. Okay, so now that we've written everything in terms of a power, we should be able to take its derivative now. So y prime would equal to 3 minus 2x to the negative 2 plus 3x to the minus 4. And then if I clean that up, this would be 3 minus 2 over x squared plus 3 over x to the power of 4. So that guy is down there, that guy is down there, and that should be your final answer there. And now moving on to question number 2 from example number 3, but for this one I'm going to try to just zoom in a little bit more so that it's very clear on all the steps that we're applying to this question here. Alright, so for example 2 here, we definitely need to rewrite this. So y would equal to 2x cubed divided by, now this root x, that's the same thing as x to the power 1/2. So I'm going to divide that by x to the power 1/2 plus 3x to the root x all over x to the 1/2. And then I have a minus 1 all over x to the 1/2. And I guess this term and that term can cancel off. And if I go ahead and simplify this, my next line would be y equals to 2. And this part right here, since the bases are the same, you would subtract the powers. So it'd be 2x to the power of 3 minus 1/2 plus 3x. And this expression right here would be negative x to the negative 1/2. And if I went ahead and continue to simplify this, the power here is, this 3 minus 1/2, 3 minus 1/2 is 2.5, and 2.5 is the same thing as 5 over 2 plus 3x minus x to the negative 1/2. Alright, let's take the derivative now. So if the 5 over 2 comes in front, 2 times, if we do this calculation on the side here, 2 times 5 over 2, the 2's cancel off, giving you a 5x. And if I minus 1 on the power now, that's the same thing as minus 2 over 2, which is 3 over 2. And then the derivative of 3x is 3. And if I bring the 1/2 in front, it would be plus 1/2 x to the negative 3 over 2. Now the question is essentially finished here. If you want to rewrite this as 5x to the 3 over 2 plus 3 plus 1 over 2x to the power of 3 over 2, you're more than welcome to do that so that you can write everything in terms of a positive power. Okay, let's see if we can move on to a few more problems now. Let me just pause the video here. We're now moving on to question number 4. For question number 4, we will use the distribution property to multiply the 6x to the 2/3 into the brackets here. On this x term right here, you might want to write that, there is an invisible 1 as a power, and if you want, you can write that 1 as, you can write that in terms of powers of, you can rewrite that as 2x to the power of 3 over 3 if you like, because when you take this term and multiply it onto that, well, 6 times 2 is going to be 12x, and if you're multiplying when the multiplying exponents where the bases are the same, you just add the powers. So 2/3 plus 1 is the same thing as plus 3 over 3 minus, and then if I take this term here and multiply with the negative 1, I get negative 6x to the 2/3. And if I simplify this, this will be the same thing as 12x to the power of 5 over 3 minus 6x to the 2/3. Now that you've distributed that, that's not f prime of x, that's just f of x. Now we can take the derivative. So if I use the power rule and multiply this through, that's the same thing as 12 times 5 over 3 x to the power of 5/3 minus 3 over 3 minus 2/3 times 6 x to the power of 2/3 minus 3 over 3. And in this question you do have to simplify quite a bit here. If I take my 12 and divide it by 3, I get 4, and 4 times 5 is 20. So this would be 20x to the power of 2/3 minus, well, 6 divided by 3 here is 2, and 2 times 4 is, 6 divided by 3 is 2, and 2 times that 2 is going to be 4, so that's going to be 4x to the negative 1/3. And finally, if you wanted to just clean this up, this would be 20x to the 2/3 minus 4 over x to the 1/3. So if you want to write your answer in terms of a positive power, that's your answer right there in the green box. Okay, let's move on to question number 5 here. So we need to continue to rewrite the radicals in terms of a power. So this radical right here in green would be x to the power of 3 over 2 multiplied onto x. Now there's really a power 1 there, so we can write that so that it's similar to the power on the outside. So maybe we can rewrite that as 2. Sorry, I'm just having a hard time changing colors in this video here. So that could be the same thing as 2 over 2 minus 3x squared. All right, let's use the distribution property now. So I'm just going to switch to my highlighter here. So this is x to the power of 3 over 2 multiplied on this first term. If I do that mathematically, that's the same thing as x to the 3 over 2 plus 2 over 2 minus 3x squared plus 3 over 2. Okay, so let's go ahead and simplify this. So this will be x to the power of 5 over 2 minus 3. And if I add 2 to, so if I do this calculation on the side here, 2 over 1 plus 3 over 2, that's going to be 4. That's going to be 3, and that's going to be 2. So that's going to be 7 over 2. So this is going to be x to the 7 over 2. All right, now that we've simplified all that, now we can take its derivative. So this power comes in front, so it'll be 5 over 2x, and then minus 1, which is the same thing as subtracting 2 over 2. So 5 over 2 minus 1 is going to be 3 over 2 minus, okay, so 7 over 2 times 3 is going to be 21 over 2x, and then minus 1, which is the same thing as minus 2 over 2, which will be 5 over 2. Okay, so that's your final answer for question number 5. I won't simplify that because I don't need to. Let's move on to questions. Actually, you know what? I'll probably just stop the video here, and I will continue on with part 2 in the second part of the video.